Hello student, in this video we will be learning about generation of FM. Now we are discussing about the generation of frequency modulation, sir. Frequency modulation means FM means what? Only wideband FM. So generation of FM means we are generating the wideband FM signal only, sir. So for generation of wideband FM signals, sir, we are having two methods, friends. What are the two methods? One is called direct method. Second one is called indirect method. Indirect method also called Armstrong method. One is direct method, another one is indirect method. Indirect method also called Armstrong method. Are you getting my point or not? Now, what is the differences, sir? What is the direct and indirect meaning there? Meaning is, direct method means directly we are generating WBFM only, wideband FM only. But here, why we call indirect method, sir? Because here first we are generating the NBFM signal. After generating NBFM signal, that is converted into wideband by using some circuits called frequency multipliers. Understand my logic or not? Here, directly in the direct method we are getting wideband FM. But in the second one, first we are getting NBFM, that is converted into wideband FM by using frequency multipliers. Both are important for objective questions asking in ESE as well as GATE. Conventional problems also asking from the Armstrong method or indirect method. That one problem I will show you in the designing part. First, let me explain the both methods. Let me start with the first one. What is the first one, sir? First one is a direct method. What we are doing, sir, in direct method is, in this method, wideband FM is generated from a device called voltage controlled oscillator, sir. What is that device, sir? The device name is voltage controlled oscillator, sir. So what is this voltage controlled oscillator? Voltage controlled oscillator means it is also a oscillator. Its oscillation frequencies are controlled by input signal voltage. So based on the input voltage varying here, the oscillations will be varied. Got my point or not? So voltage controlled oscillator means depending upon the input voltage, output frequencies will vary. I understand my point. Means if I give the input is our message signal, according to our message signal, output frequencies are going to be varied. According to voltage, message voltage, frequencies are varying means what is that? Called frequency modulation. So output you will get a FM signal. So the first objective question they are asking in ESE. VCO is used in the direct method of FM. VCO used in the direct method of FM. Next. If you cleanly look into that VCO, what is the tuned circuit we are using and how it is operating, let's see. If you see this one, VCO voltage controlled oscillator, what is there inside is an Hartley oscillator we are having. What we are having? An Hartley oscillator we are having. Hartley oscillator means two inductors are in series with a parallel of capacitor. Let's take L1, L2, C1. That Hartley oscillator is connected by another one diode. Here across this we are connecting one diode. Can you say name of that diode? By seeing the symbol itself you can say. What is the name of the diode? It is nothing but, yes, exactly, varactor diode, sir. What is the property of a varactor diode, sir? based on the biasing voltage offered across the varactor diode, the capacitance is going to be vary, sir. So that's why it is also having another name, voltage variable capacitor. That is VVC, are also called varicap. Varicap means variable capacitor. Across this varactor diode, we are connecting our messages. Now let's see. Depending upon the message voltage, biasing across the varactor diode is varied. If the biasing is varied, the capacitance offered by the diode is varied. If capacitance offered by the diode is varied, the overall tuning frequency or tune frequency will vary, or resonant frequency will vary. What is the resonant frequency formula for any tuned circuit? The resonant frequency is 1 divided by 2 pi into root LC. Here, sir, 1 by 2 pi root LC. L means what, sir? Two inductors are in series, so L1 plus L2, sir. C means what, sir? Two capacitors are in parallel, so C1 plus C2, sir. So here what is happening, sir? Whenever M of t voltage varies, capacitance offered by this diode will vary. If C2 is varying, according to that, frequency is varying. It is becoming FC whenever there is no variations. Whenever M of t is 0, we are fixing some value. If M of t is 0, we are fixing some value, that what will give you FC. If whenever M of t is varying, C2 will vary. According to that, frequency is also vary. So that is called frequency of FM or instantaneous frequency. Understand my point? Now I am explaining this one in two cases. If message is positive and message is negative. Let's take case 1. If M of t is positive. If M of t is positive. M of t is positive, let's see in the parallel case here. Case 2, I will show you if M of t is negative. I am taking the main circuit in a tune because the overall operation is depending upon this varactor diode and remaining are fixed. So take the varactor diode. Across we are connecting the message M of t. Here in the first case, M of t is a positive. M of t is a positive means this is the actual way of giving connection. But here what we are using is, students, we are using the reverse connection. Why we are using? To get our required thing. Reverse means change the terminals of a wire. Change the terminals of a wire means it will be minus plus. Then let's see the diodes, sir. Minus plus means diode is forward or reverse biased, sir. Negative to positive, positive to negative. Diode is reverse biased. Diode is reverse biased means depletion region increases or decreases, sir. Reverse bias means depletion region increases, sir. Depletion region increasing means what? Width of the depletion region is increasing, sir. Width of the depletion is increasing means C2 equal to epsilon A by W, sir. Formula. Here, what is happening? See, the width of the depletion is increasing, sir. Then capacitance will decrease, sir. See the formula. If C2 value is decreasing, denominator is decreasing, sir. then what about the frequency will increase? Are you getting my point or not? Frequency will increase. We already know m of t is positive means frequency will be increases. See the negative case, the main. Here m of t is negative means this is the actual way of connection. Generally, m of t negative means like that it will be there. But here we are using reverse connection, so it will be plus minus. That is the thing. Now see the what about the diode? If you see diode is forward bias, then depletion region what happened? Decreases. Depletion is decreases means W decreases. W decreases means C2 equal to epsilon A by W. Here epsilon means permittivity of that material, A means area of cross section of depletion region, and W means what? Depletion region width. Here what is happening, sir? W is decreasing, sir. If W is decreasing, what about C2, sir? C2 will increase, sir. If C2 is increasing, what about frequency, sir? Frequency will decrease, sir. We already know whenever m of t is negative, frequency decreases. Have you got my point or not? Yeah. This is about the direct method of a FM generation. So for FM generation, two methods. Direct method we already discussed. What are the two objective questions they will ask from the direct method is VCO is used in direct method of FM. Another point is varactor diode. Varactor diode we are using in the direct method generation of FM. Those are the two objective questions they will ask. Now we will move on to the indirect or Armstrong method, because there is a one drawback in the direct method. What is the drawbacks are in the direct method? Generally, what is the carrier frequency we are generating, that is FC, it should be constant. Now that constant value we have to vary with our message. Are you understanding my point? Now, for generation of stable frequencies, what we will use? Crystal oscillators we will use. But here we are using Hartley oscillator. So what is the FC itself we are generating? It is not a constant, itself having some fluctuations. So FC itself is having fluctuations means generated signal will have some fluctuations. So they tried with, in place of varactor diode, we tried with the different circuits, variable capacitance, variable inductance, like different things we tried. But varactor diode is somehow better. So what is the thing will happen here is, when m of t is 0, it has to generate a carrier frequency. That FC itself is not a standard or stable one because of Hartley oscillator. So for generation of stable and sustained one, what we have to use? Crystal oscillator I have to use. But crystal I cannot use here, because even if you connect anything to the crystal frequency does not vary. But my stable frequency has to vary according to m of t. But because of not using crystal, when m of t means 0, not message applied, what we are getting is carrier. That carrier should be constant, but constant carrier we cannot expect from the Hartley oscillator. That I am going to be avoided, or we are going to be avoid that problem in the indirect method. Here for generation of carrier, we are taking a crystal oscillator. So what we are doing here? First to generate NBFM, later that is converted into wideband, students. Converted into wideband. Okay.